Okay, good morning everyone. Welcome to the next presentation of the session. The presentation's called Clocking the Telco Cloud. We're actually going to be talking about a specific aspect in data centers, which is precision, timing, and synchronization. So the OCP has a project called the Time Appliance Project, TAP. If you look at the far end of this show floor, there is the Experience Center, and you can come and see 6 demo stations of what the Time Appliance Project is all about. Now, Time Appliance Project is one of the 12 projects in OCP. It was started up really to look at the area of clocking, timing, and synchronization in data centers. So why do we need precision timing in data centers? Well, fundamental requirement for synchronization is really to synchronize computers and everything that run on the computers. So all of the servers in a global hyperscale center or in a data center, if you synchronize those computers, you can effectively make them more efficient. If you reduce the window that you need to wait before you can write or read the next instruction, you can effectively do everything quicker. Now, if you can do everything quicker with the same hardware, that's worth a lot to the data center community. So synchronizing computers or servers around the world enables and facilitates more efficient operation. It also enables a lot of cool things. You can now do a lot more accurate telemetry. Telemetry, of course, is hugely important to measure load and traffic in a data center. And then one of the other critical areas that's important for timing and synchronization is the telco cloud. The telco cloud fundamentally is simply a telecoms network sitting on a hyperscale infrastructure or a data center infrastructure. A telecoms network in this case is really referring primarily to a mobile network. Let's say a 5G mobile network. So if AT&T wants to run their 5G mobile network on a data center infrastructure, that's what we are referring to as the telco cloud. They can utilize Google Cloud or Azure or AWS as the infrastructure or have their own data center infrastructure. But to run a telco or mobile network needs accurate synchronization. Why? Because the 5G radios need to be synchronized to operate correctly. So again, there is a huge growing need for precision timing and synchronization in data center. And that is what the TAP or Time Appliance Project looks at. And as I say, once again, come and see some of the projects at work at the Experience Center. So, my name is Anand Ram. I work for a company called Calnex, and we're involved with the OCP Time Appliance Project. So in previous years, we've talked about clocking the cloud, why you need precision timing in data centers. So today, we're really going to be talking about, as I said earlier, the telco cloud, clocking the telco cloud. The telco cloud in the early days was simply disaggregated platforms. So you started by disaggregating switches and routers and telecoms infrastructure equipment and having software run on white box or bare metal platforms. So that was the first step of migrating the telco infrastructure to the cloud. Then there's been a lot of other initiatives like software-defined networking, running functions and functionality on containers, and automating the telecoms infrastructure network. So AT&T has had a long project to effectively take its infrastructure into the cloud. And then initially, we had deployments with taking the mobile network functions and running them on the cloud. Now, this started initially with things like the core network, the mobile core. So again, AT&T took all of the functions of what we call the mobile core network and put it onto the cloud, ran it on the cloud. But increasingly, telcos want to run the rest of their infrastructure on the cloud as well. So why do they want to do that? Well, first of all, it's way more flexible. Telecoms infrastructure is notoriously not flexible. In order to upgrade the infrastructure for telecoms 5 years ago, took a lot of time, money, and effort. So moving to the cloud enables a lot more flexibility for a telco to deploy and deliver new services. And then, of course, the economies of scale are huge. The cloud infrastructure overtook the telecoms infrastructure globally a long time ago. So you get way more economies of scale if your network is built like a data center rather than a telecom switching center as it was in the past. But as you say, the cloud infrastructure is a cloud infrastructure. It's not telco, and the telco companies are telco companies. AT&T famously 5 years ago went to all of its technicians and said, "We want you to be like Google technicians." Just like that. And of course, the mindset, mentality, technology, and expertise is very, very different. So here are some of the things, and of course, timing and synchronization is another technology that's different. It always existed in the telecoms infrastructure, but it wasn't necessarily a critical need in the data center infrastructure. So we're going to look at an example of Dish Network. So many of you may have heard of Dish Networks. It's a network that's going to be launched in the US. It should have been launched already, but it's coming soon. And they're building their entire infrastructure on the AWS cloud. So this is basically a telecoms network where they would then use the AWS regional, local zones, and outposts to run telecoms functions in that over the AWS platform. Now, the key thing here is, as I said before, telecoms network needs has critical hard requirements for timing and synchronization. The key one to notice down here is 1.5 microseconds from the core to the edge of the mobile network. So 1.5 microseconds alignment is required in that infrastructure. If you take that 1.5 microseconds requirement and put it into the cloud infrastructure we just saw, that means we need to be synchronized to 3 microseconds to a central clock for the what we call the outposts, and the radio has to be synchronized to plus or minus 1.5 microseconds. A data center or cloud infrastructure operating today generally is synchronized, but it's synchronized to hundreds of milliseconds. That's nowhere near enough for the telco infrastructure to run on it. So these new synchronization requirements are coming in if Google Cloud, Azure, AWS want to run a telecoms network on their infrastructure. They need precision timing and deliver precision timing and synchronization. The good news is that the Time Appliance project at the OCP has actually set up the framework, and there's a lot of work going on to enable the data center infrastructure to deliver 1.5 microseconds across its network. You'll hear more about that tomorrow. So tomorrow afternoon, there's a stream of talks specifically on the Time Appliance project. You can filter on that on your agenda. It's going to be in the room across the hallway there. So there's going to be, I think, 6 or 7 talks specifically on this topic. And then also, as I said, please come over and to the Experience Center, where there are projects going on talking about how data center infrastructure will be able to deliver precision timing and synchronization for services like the telco cloud in the future. Okay, thank you very much.